We want to make this interactive and as formative as possible. And as my second grade school teacher, Mrs. Waynick, used to say, there's no stupid question. So if you have a question, just throw it out there. So let's go, Bill.
Thanks, Chris. Thanks, everyone, for joining the call. Chris, you've been around the block. Can you tell us in the last couple of years what you've seen and experienced in the outdoor lighting market? What changes have you seen, and what's really driving things as time goes on?
That's a great question, Bill. And I think if you look at sort of outdoor lighting in general, there are a couple of interesting statistics that are important to begin with. One is that outdoor lighting consumes about 19 to 20% of the total energy spend globally. This data comes from the International Energy Agency. If you look at a typical city, about 40% of their electricity spend is outdoor lighting. So that's a fairly significant number. And what's also interesting, I just found this out just this week, is that if you look at new deployments of outdoor lighting, over 50% of the lights that are being installed are LEDs. So there's a rapid migration of retrofits moving from the legacy high-pressure sodium and HID lighting to LEDs. So what we're seeing is that more and more cities and utilities are upgrading their lighting infrastructure to LEDs and adding controls. There's a fairly rapid adoption of that going on. This phenomena is taking place not only in the Americas, but also in the Middle East, Africa. There's an organization there called the Smart Africa Alliance. It's a group of now 24 countries, and they're looking at upgrading to LED lighting infrastructure. There's a lot of work going on in Asia Pacific. Singapore is a great example, Smart Nation project, and then we have Australia and New Zealand. I think one of the bigger changes that's going on besides the technology is really the way these projects are undertaken and implemented. What we're seeing is there are new collaborative business models evolving where you have anywhere from 5 to 6 animators in a project working together. You'll have a prime. This could be an energy services company. There's often engineering consultants involved. You have the luminaire manufacturer, technology providers, controls providers like CIMCON. The utility is now more and more involved, and then, of course, you have the network infrastructure providers. But you're also seeing a much higher level of engagement with the city leadership. Before, when cities were upgrading their lights, they would be dealing with the utility department or the lighting guys. Now you have the mayor, the chief information officer, the chief technology officer involved. And the reason for that is that these projects are really a blend of operational technology and IT technology, and they're much more IT-centric because these are network systems and a lot of data is involved. So that's why you're seeing these other players enter into the equation. What's also interesting is that there are new funding models that are coming out to enable cities to be able to upgrade their lighting to new infrastructure. So public-private partnerships, energy service agreements, lighting as a service. These are approaches that allow the lighting infrastructure upgrades to become cash flow positive, where the energy savings more than enough pay for the project. What I find really fairly significant is that in the last 4 or 5 years, you have new players trying to enter the market. Your service providers, which is your telcos. You have IT service companies, communication companies, Nokia, CenturyLink, Charter. And you have Cox and Comcast. They're trying to gain a foothold in this space. So it's really an evolution of them trying to diversify their business base and gain new revenues. But at the end of the day, it's all about data and it's all about networks to improve situational awareness and to help cities and utilities become much more efficient. So Bill, when you look at smart lighting, because I know you've been in this space also for a while, what are some of the key benefits that cities and utilities can expect? Could you elaborate on those a bit?
Yeah, the first major driver is energy. And the end of life of the lighting technologies that were invented quite some time ago, actually, that involve an excited gas in a evacuated tube. That technology is going by the wayside as LEDs displaces those sodium and mercury vapor lights. We see an immediate reduction in energy usage, and that's really just the start of it all. What you also get with LEDs that's much more difficult to get with the legacy technology is controllability, the ability to dim the bulbs. There are technologies that allow you to dim other types of fluorescent lights, sodium and mercury fluorescent lights, but it adds a lot of cost and complexity, as well as additional points of failure. And with LED, that all becomes much simpler. Everything is solid state, right up and including the drivers themselves. So you get immediate energy savings, and you get immediate flexibility in the use of the light. So you're able to dim it to several different degrees at night rather than just have a simple schedule which allows it to be dimmed, let's say, between 10 at night and 4 in the morning, or 1 to 5 a.m. or something like that. You know, a lot more flexibility there. But in addition to that, you get benefits from class of applications, which I think of as asset management. What is the state of the light right now? Is it on? Is it not on? Is it supposed to be on? Is it on at the to the degree that it should be on? And can we gather that data in real time or in near real time to keep the lights on, literally? This leads to labor savings in maintenance of the fleet, which is another major cost. So in the old days, you needed to drive around and look at the lights at night and see which ones were off, write a trouble report, and then later roll another truck to go out and replace those lights. With a network system of smart lighting, you know almost immediately that the light is out, and you can gather up your staff for a shift of repair work, and then they're fully operational during that time, going right to the lights that are not working and getting them repaired. Also coming about are new applications built on top of that. So we're deploying today an outdoor safety application, which we think of as the blue light or the blue button. We're deploying environmental sensors. We're deploying people counters on sidewalks, as well as counting traffic in lanes, and we're integrating a variety of technology to do that, including video analytics, radar. We're using Wi-Fi sensors to detect Wi-Fi devices as they move around the town. And we're integrating all those sources of information to provide a view of what's really going on there. And we also piggyback on the networks that may already be in place with the utilities. So there's been a separate evolution in metering. In the old days, somebody would come to your house once a month and write down the number that he read off of your meter, and that's how your energy bill was calculated. That evolved into a system where he really just needed to drive by in a truck, and a low-power radio on the meter would talk to the truck as it drove by. And now we have a fully meshed network where each meter can talk to its neighboring meter, and the hop from meter to meter eventually gets back to an internet-connected gateway, and that's how your electric bill runs today. But when we deploy a streetlight network, we can use that same network, and it makes a lot of sense to use that same network. So you don't need another skill set, another set of training, another silo system for another radio, but you're able to make use of the system that's already deployed. And the other big benefit, I guess, that sort of falls out of that is what's called Metcalfe's law. The nature of networking and the value of a network is proportional to the square of the number of participants in the network, because each participant in the network can talk to many others. And anytime you add one, he can also talk to many others. And there's a square factor that goes on there about the utility of the network.
That's great, Bill. And, you know, just to add to what you said, I think there are a couple other factors. We obviously work with utilities quite a lot, and because the streetlight controllers, in our case, have power meters inside, it really gives them a much better view of the grid and helps them better manage the voltage all the way to the last endpoint, which could be a streetlight controller. If you go back to the asset management and fault detection and things like that, the data that comes from the Energy Information Agency is that if the street light is unconnected and not controlled, it takes about 2.6 truck rolls for that light to be repaired. One, to either to diagnose it, that there's it's not burning at night or it's burning during the daytime, or to validate that the complaint a citizen sent in is true. The second truck roll is to roll the truck out and hopefully fix it the first time, but often that's not the case because they don't have the right parts, because they don't know what type of luminaire it is. So the average is about 2.6 truck rolls to fix a light. And if you're in a state like the Commonwealth of Massachusetts, you have to have a police officer there directing traffic around the bucket truck. So going from 2.6 truck rolls to 1 can save a significant amount of money. If you look at this generally well-accepted concept that smart and connected lighting is probably one of the primary and first applications to becoming a smart city, how is it that smart and connected lighting infrastructure can enable some of these other applications that cities are looking for to become smart? What are sort of the underlying principles and prerequisites that cities need to consider?
So I tend to think of these things in evolutionary terms. It wasn't so long ago that streetlights were a fellow with a magic key, and he would walk along to each pole and turn on the gas valve and had a flame on a stick and would light the street lamp. And so that's progressed through several stages, as I mentioned, through the use of fluorescent bulbs, excited gas bulbs, and today to LEDs. But what's really forming up there now is a kind of a nexus of intelligence up on the pole. There are lots of applications now that can be put up there once the pole is connected and once power is available. I do want to point out one thing, Chris, about the truck rolls, and that is that when those lights are out and until the survey is done and the truck is rolled, those lights are still on the tariff. So the town or whoever's paying the electric bill has to pay for that light even though it's out. And that's one of the things you get with smart and connected lighting, is knowing that the light is out and the ability not to pay for it when it's broken. So what are some of the applications that we can put out there? I think we're going to have to jump ahead, Heidi, to quality of life and some of these other things, and we'll come back. Slide 10, let's say. So what are the quality of life enhancements that we can implement using this valuable real estate that we have on the streetlight, the real estate and the network? We're putting up air quality sensors in urban locations. We can determine if CO2 or nitrous oxides are building up. We're looking at hazardous material detection along railway lines. One of the interesting things for me was that railways are federally regulated, and cities and towns have no idea what's going through their town centers on these trains. If there's an accident, the train is required to have a printed manifest on the train of what the contents of the train cars are. So what happens in case of an accident is the first responders need to kind of go through the rubble and look for that manifest to find out what chemicals are actually in the train cars. So by putting up sensors along the railroad rights of way, we're able to kind of sniff and find out what's going through the town and be better prepared rather than waiting for an accident. We're able to know ahead of time exactly what that is. You'll notice that railway cars have a placard on them. It'll say explosive or it'll say corrosive or various other hazardous warnings, but it doesn't really tell you exactly what's going on in the rail car. And there are some nasty chemicals. Vinyl chloride gets shipped all over the country. For some reason, molten sulfur is a common commodity that gets shipped all over the country. And also crude oil from central Canada and the northern U.S. The so-called shale oil is often shipped by railways, and it's highly flammable in case of an accident. There was an accident in Lac-Mégantic in Quebec a few years ago. A couple of railway cars came loose, rolled down into the town, and burned down 3/4 of the town. It was quite a tragic accident in a pretty little resort town in Quebec. So those are kinds of disasters that we can help to prevent by instrumenting the pole and knowing what's going on around there. As I mentioned, we're using a variety of sensors, including electrochemical sensors, gas-sensitive sensors, camera, radar, Wi-Fi counters, and so on. Some of the other advanced applications that we're looking at are gunshot detection. You've probably heard of one or two companies that are in the gunshot detection business. They look for the sharp report of a bullet traveling at supersonic speed, and they also look for the muzzle blast itself. And by putting up various microphones around, they're able to triangulate the source of the original sound and and try and pinpoint the source. The problem there is that you need strategically placed microphones. Those microphones have to be powered. They have to have a way for their data to get back to this central analysis location so that somebody can actually listen to it and determine that it is a shot. And so that's what we really provide at CIMCON is power, metering, communications, and processing there on the pole. Those are the key elements that allow what's a streetlight network, a relatively simple application, to be leveraged for something much more powerful. And so, Chris, city officials and utilities that are planning to implement smart cities applications have to make choices as to which networking technology is best suited. So there's a variety of them, and CIMCON supports many of them. All the applications involve remote assets, outdoor assets, and they all require a means of communication. What do you advise to the city and town thought leadership as far as networking goes?
That's a really great question, Bill, and it is not simply answered, to be quite candid. But I think as a starting point, you need to look at, what are the typical smart city applications that cities want to implement. And I divide them into two categories. The first would be mission critical, and the second would be those which are economically beneficial. And it's important to realize that no one technology is going to satisfy the requirements of the types of communication networks that are required for these. So let's talk about mission critical applications first. A very important one is critical infrastructure monitoring and control. We also have intelligent traffic systems, stormwater management, video surveillance for public safety is another one. Streetlight controls, some people would throw school crossing signals into that mission critical category. The other class is what I would call the ones that are economically beneficial. Advanced metering, taking meter readings from your electric, water, and gas meters. Refuge management, is the waste bin full or is it empty? Asset tracking, where are my city assets? Picking that up. Environmental sensing. This one I liked, manhole cover monitoring. Is the manhole fully inserted into the collar in the street so that a guy on a bicycle doesn't fall down the hole? Parking lot management, and probably a very popular application that's not what I would call mission critical, but maybe it would be, is public Wi-Fi access. Depends on who it is. So these are the two categories, and I think that if you look at what are the communication network considerations for those that are mission critical. For mission critical, if you have a network failure, that could have very critical consequences in terms of loss in life or property. So because of that, these networks are typically dedicated. They're engineered to deliver a very specific capacity, availability, and reliability. The spectrum that they use, if they're wireless, is protected. Information assurance is absolutely required. And the business case is not purely economic. So these networks are typically purpose-built. If you look at the networks that are business beneficial, and we talked about those, advanced metering, asset tracking, environmental sensing, and the like, the data is not really time sensitive. If it takes a few seconds to get there, that's okay. The networks are more architected for coverage first. How broad of a network can I deploy out there? Often the networks are shared, back to Metcalfe's law. Utilities will put in smart grid networks that monitor the meters, but also they might run streetlights on it. Typically the spectrum is unlicensed, and the business case is hugely economic. So you're really talking about sort of a shared services total cost of ownership consideration. So that's kind of that, but it's not an easy problem, and it's imperative that cities work very closely with people that are deploying these networks to understand all the issues that are involved. So Bill, we've talked about smart outdoor lighting, the ROI. We've talked about some of the benefits of deploying other applications on smart and connected lighting. So what are some of the challenges that cities and utilities face in deploying these smart city applications outdoors? And what are some of the existing technology gaps in terms of adding instruments, controls, sensors, instrumenting, connecting to that physical world of city assets outdoors? If you please explain.
Yeah, well, what it comes down to is the four basic functions, which are power, metering, secure data communications, and processing at the edge. So power is generally accomplished by tapping it off of the streetlight head. There's an industry standard connector there, the ANSI C136.41 standard, and it's pretty easy to buy a connector and plug in there. The second problem you run into, though, is that someone has to pay for that electricity, and so it needs to get metered. And so CIMCON is expert in that. We do that today for our streetlights, our streetlight controls, and we do that as well with our NearSky device, which I'll talk about in just a moment, which provides the secure data communications and edge processing. So that's the sort of the original barrier that anyone needs to overcome to put out a new application out there on the streetlight using just what's there. If we look at slide 8, Heidi, this was my conceptual view of the problem that we were trying to solve. When I joined CIMCON, we had an idea for a super smart controller there, and my job was to kind of sort out what it's supposed to do and where it is supposed to fit in life, and it looked to me like a micro data center. And I had some experience in the data center business before, on a range of sizes, I guess I would say, and it looked very much to me like we were making a data center for a specific place on the Earth. And if you look just at the top of this diagram, you'll see that there are data centers in space. There's a company called Space Belt, and their entire business model is built on data sovereignty. So if you store your data out in space here on their data center, it's not subject to any of the discovery laws of terrestrial governments. It's kind of a fantasy today, but it's out there. CubeSats, on the other hand, exist today. Anyone can build one. With a few bucks, you can put your own experiment into space. In the area I think of as the middle sky, that's flight. You're disconnected from the Earth. You have to bring everything with you. All your power and communications has to be right there, and you're disconnected from the Earth, and so clearly you've got a limited lifetime that you can operate. At the bottom is terrestrial data centers, which we may have seen or heard of, and they come in all kinds of shapes and sizes, everything from something that fits into a cabinet or a railroad car, or a transportation container, all the way up to giant warehouse type of installations. And so where do we operate? Well, we operate in this area, which I call the NearSky. The NearSky is above our heads. If you look up, you can see it, but you can't hit it with a rock. And you can connect to it with a wire, which is a big advantage. It's the biggest distinction between the NearSky and the middle sky is you can reach the NearSky with a wire. And with just a wire, you can do quite a bit.
Yeah, I kind of describe it, Bill, as that space of these networks and data flowing back and forth, somewhere slightly below heaven, down to Earth.
And not quite to the Earth, but and definitely below heaven. If we look at slide 9, Heidi, this is our next version of the NearSky 360. We're calling it an Edge Hub, and it provides those key features of power, metering, communications, and processing. If you notice on the right-hand illustration, the ANSI connector there is shown on top. The mating connector is underneath this device, so you can pop it on top of a streetlight. It obtains its power. It's got Wi-Fi for backhaul. It's got Ethernet for backhaul. It's got power over Ethernet to run a camera right on site, and a bunch of other nifty features. And also it has that same ANSI connector on the top, or a so-called NEMA 7-pin connector on top. And so you can put a standard streetlight controller there, and the streetlight will continue to operate the way that it always has. I guess I'd like to talk a little bit, Chris, about some of the advanced or exotic applications, if you're interested. I mentioned gunshot detection.
Yeah, that's one.
But we were presented with a challenge by a city in the Northeast, which we might call a Rust Belt city. They ended up, after the last financial crisis, with a fleet of abandoned homes. And They get gradually decrepit in the town. They're unpowered. They're victims of crime, the houses are. People will break into them, steal the copper and so on, until eventually somebody burns it down. And there's been several tragedies in the city around it. One was 4 people died directly across from City Hall in an abandoned house. It caught fire. Some homeless people were in it. I don't know if it was a crack house or what, but right across from City Hall, and 4 people died. Each one of those incidents, whether somebody gets injured or not, costs hundreds of thousands of dollars to roll the fire department, and it leaves behind an even bigger mess that needs to be demolished and cleaned up. So we call that zombie house, the zombie house application, and we can make use of the streetlight network that passes by and put some sensors in the house to listen for noise, detect temperature changes, detect light changes, and then report that smoke and fire. And even vibration, and send that information over the streetlight network back to someone who can come by and take a look and see if there's anything going on in the house.
Yeah, Bill, there are lots of really interesting applications, and I think if you look at this whole space, cities and utilities are looking for platforms that they can very flexibly deploy these new types of applications and make sure they work, and then have multiple applications running off, for example, like one NearSky. And I'll give you an example of an application. We did a project in Africa in association with the Smart Africa Alliance. The pilot was to put in LED lighting both in a capital city in this country in Africa and then along a rural highway, and to validate the economic benefits of deploying LED lighting and controlling them. One use case that came out, particularly along the rural highways where the people that live near those in villages don't have electricity. I just learned this past week that only 1% of the population in Niger, for example, in Africa has electricity. So, interesting statistics. So, anyway, back to this other country, the use case was homework. And what would happen, the kids would come out at night during the evening and drag their book bag and little chair or stool or table or whatever they had and do their homework under the street light. It was LED, much better quality than the illumination they could get from their candles or gas lanterns that are inside the house. And so that was a really pleasant, unexpected application that came up. And the flip side of that story is that the company that was involved deploying them had to use satellite backhaul because there was no cell service out where these lights were deployed along this rural highway. And so at the same time, they put in a Wi-Fi access point where the street light is providing power to the satellite dish. The communications backhaul for the controls is over satellite communications, and they're also delivering Wi-Fi. So if I think about that scenario, and I can just picture those children doing their homework, what type of economic benefit could come from having digital equity Wi-Fi access and the ability to have good lighting to do their homework. So what you're going to find is that cities are going to come up with a lot of new ideas that and application needs that they're going to want technology to be able to deploy very quickly and readily, prove it out. Another application that I thought was way cool, I had the privilege of speaking a couple weeks ago at a conference in Amman, Jordan, and some of the smart city practitioners that were there were from Dubai, and they showed me a smartphone application called Dubai Now. And it allows citizens and workers to access over 50 different city services from one smartphone app coming from 22 different departments. So think of the time and energy and aggravation that one could save if you could just, via your smartphone, pay an electric bill, make a deposit, renew your driver's license, get a new license plate, whatever, where you don't have to go down to the RMV, stand in line. It's not a fun thing. So there's just lots of really interesting applications that are coming out. we should talk about maybe some of the ones that we're working with in different parts of the, you mentioned the rail line monitoring. What about others, like down in Florida?
Sure. I'd just like to mention on the homework scenario, that's something that's really enabled by the use of controls. You could turn the light on for 12 hours a day, and then the light would be on at night, and they could still do their homework, but that's not likely what people would think of. They would try to control the energy costs first, and nobody would be thinking that kids might actually use it for homework. And it's only by going out and doing it and installing the controls and having the flexibility to experiment and make changes that you're able to discover an application like that. So I think that's one of the great ones.
Yeah, I mean, in that particular case, the LED street lights were oversized, as they often are. And so during normal operating non-homework hours, the lights are probably dimmed about 30–40%, but when the kids come out to do their homework, they brighten the lights to 100% so they get the best illumination possible. And then when the kids get ready to go to bed, the lights go back down. And that's only enabled by controls. So
yeah, that's right. And there's some other non-economic benefits, such as light pollution. So most of the time that street lights are on at night, they're not being used for anything. They're lighting up nobody. They're lighting up empty streets. And so when you have active lighting, motion-sensitive lighting, for example, you're able to turn the lights on when people need it and turn the lights off when people don't need it, and not only reduce the amount of energy, but just reduce the general amount of light pollution and how brightly people are surrounded when they don't need to be. Weather anomalies is another interesting thing. So one of the great benefits of the streetlight network is the ubiquity of it and the low cost. So it's everywhere. It's every few yards, every 50 yards, however far apart your street lights are. And so you have a very dense network. And for detecting weather anomalies, that can come in very handy. We were contacted by an electrical utility in the central Midwest, Tornado Alley, and they're wondering what can they do to help mitigate the damages of tornadoes. Obviously, they can't be prevented, but what can we do about them? And with a dense network of sensors along the streetlight network, we will be able to detect those and determine what path they're on, and also get some indication of the severity. And that should help to provide first responders with better information to respond more closely to the actual incident.
Yeah, Bill, there's another similar utility application called galloping lines, and again, happens to be in I'd say the lower Midwest, in the Great Plains. And the problem that the utilities encounter is that during the winter, snow and rain and freezing rain and ice storms coat the power lines with ice, and as they gather more and more snow and ice, they start to sway and whip and gallop, and so the lines bump into each other and they short out. So in this case, the utility was looking, like for the other monitoring you talked about, to deploy low-cost weather stations to understand what are the actual weather conditions that cause these galloping lines to occur, thinking perhaps that there might be ways to mitigate that by having better access to data. So lots of things, and in this case they were using the NearSky to power the weather stations and using the streetlight controllers to get the data back from those. Mm-hmm. So they took what formerly would be just an isolated, hanging on a pole device and make it smart and connected via the NearSky hub or edge.
So those are the fun and exciting ones. We have deployments with a little more prosaic application. There's a lovely small city in Florida that's instrumented their main shopping street, the high street in the town, and they're able to track people's congregation at corners waiting to cross the street. They're able to determine who's using which traffic lane, how many people turn right, and so that's ongoing today. And that just helps to better manage people, better manage the assets in the town. It lets the commercial businesses know that they're perhaps being cut off from the parking lot rather than have the parking lot be a source of customers. There's actually barriers in between, and that's the kind of information you can get with dense sensing. The other thing I don't want to forget to mention is connected vehicles. So connected vehicles are an emerging topic. We've heard a lot about autonomous vehicles, but there is a step in between total autonomy and today's, let's call it manual mode for driving. and that is a connected vehicle. And vehicles, commonly when they're surrounded by many other vehicles, they're also surrounded by a streetlight network. And so cars will be able to communicate with that streetlight network for precision positioning, for traffic warnings, for many other kinds of things that can help automate the flow of traffic, reduce the number of accidents, reduce the possibility of human error.
In that case, it's called digital short-range communications, and one of the problems is how do you deploy these communication devices in a dense enough manner so that cars can pick them up as they drive by. And so that's an area where these DSRC access points, these radios, can be deployed on streetlight infrastructure. There's another one that has yet to be proven in terms of what the actual potential would be. The principle, the concept is certainly assured, and that's small cells or smart cells on streetlight poles. If you look at Pacific Gas and Electric, for example, they've deployed a number of smart cells around Levi Stadium in Santa Clara. That's where the 49ers play. And they want to improve the cell coverage and bandwidth around that event venue during football games and other concerts. So in that case, the small cells, which are operated by AT&T, they go on the pole. I think the equipment came from either Ericsson or Nokia. And in this case, CIMCON actually provides the revenue-grade power meter that meters the electricity that the small cell uses and allows PG&E to build the tenants of that pole. In this case, if you look at some of the different regulations across the U.S., if you want to mount another service on a streetlight pole, and it's important to understand who owns that pole, is it the city or is it the utility, there are pole attachment fees. And so those can run anywhere from a couple $100 to $2,000 a year, let's say, to put a small cell up there. All of the service providers are now touting their upcoming rollouts of 5G communications, better coverage, higher bandwidth, yada, yada, yada. And those cells are going to need to be very closely spaced toward each other. The numbers I've heard is up 500 meters at most. Maybe that's not correct. 500 feet, I don't remember. But anyway, much more dense coverage than what you have with LTE 4G. So the cities or utilities have a real opportunity to deploy and rent poles to these service providers, AT&T, Verizon, Sprint, and so on, and earn revenues, and then utilities, if they were to use our NearSky device, could power those cells on the streetlight pole, and with the meter inside also bill for it. So there's just a lot of stuff coming. It's outdoors, though, and I think that's the key point, is that we're really looking at this evolution of the Internet of Things outdoors, and we at CIMCON feel very strongly that the NearSky Data Hub and the NearSky Street Vibe software that supports this environment will be very instrumental in pushing IoT outdoors fast forward.
Is this a good time for questions, Heidi?
I think so. So if you'd like, please use the chat function. Okay.
So we had one question about the tariffs and how they get paid for, and so that's an evolving part of the economy. For historical reasons, utilities have relied on traditional electric meters for most loads, but streetlights are often handled through estimates and fixed tariffs. So whatever type of device you have out there, it falls in a tariff bucket, and you pay that much every month for that streetlight, and there's some estimate based on how many hours you're going to burn it and what dimming you might have in a fixed schedule. That's proven not to be adequate in many cases. People don't really use the light or wish to use the light in the way that's been scheduled. People are much more ad hoc about it. They don't plan ahead and say, I need light for 6 hours at night. When they show up, they expect the light to be on, and when they're not there, they don't really care that much about the light. So active controls really helps to better tailor the use of the light to people's actual desired behavior.
Okay, we have another question. Can the NearSky hub be used on another light network?
Well, we support a whole bunch of different networks, so probably the answer is yes. Which one are they using? It would come down to which one are they using, but we support a wide variety of networks. We are not dependent on particular network providers.
Maybe we can be very specific. So if you look at the NearSky hub, it allows you to connect to various devices that are attached to the pole. And the networks that we support through the Streetlight controller are Zigbee, Silver Spring, Cisco, and Ingenue RPMA/Trilliant. The next version of the NearSky Edge device will also have cellular backhaul in it, 4G LTE. And we also, in that hub, have Bluetooth and Wi-Fi. So the Wi-Fi would allow the hub to act like a client, not as an access point. So if you have a very specific question in terms of what network, we'd be happy to learn more specifically about what you'd like to do. Bill, talking about tariffs, I think it's important to point out that if you look at many utilities, they've operated traditionally in the regulated space where they're selling power, gas, whatever, to both commercial, industrial, residential, and government customers. And with the conversion of lighting to LEDs, where the energy consumption is halved and controls, which means it could be reduced even further, and the integration of renewables into the grid, solar, wind principally. Utilities are looking for new revenue sources in the unregulated space. So there are a number of utilities across the U.S. that are starting to offer to their customers, both inside of and outside their service areas, services like that we talked about today. And so the NearSky is a good way to help utilities fulfill and enable those strategies of business diversification and new revenue sources. Same applies to cities if they own the poles, if they own the lights. So it's very important to understand what the ownership of those assets are. Any more questions, Heidi?
One question came in about pole attachment fees, also related to tariffs. And so that is a rapidly evolving economic balance, I would say, between the utilities and the ratepayers. In Massachusetts and in New York, they've passed laws recently which allow municipalities to implement compulsory purchase of the streetlight assets. So if they feel that they're getting kind of a raw deal from the utilities, they're able to force the sale of those assets to the municipalities at their amortized value, which is often low, and begin maintaining that themselves. That often requires an ongoing deal with the utilities, and the municipalities often don't really fully maintain them themselves, but continue to pay the utility for some part of the service. And so there is a fee that needs to be there to account for the work that the utility really does need to do related to the continuing existence of the streetlights on the pole. However, the streetlights themselves would then be managed by the utilities, by the municipalities. Got another one?
Yeah, okay. So the question was, would this environment support digital short-range communication for connected vehicles? And the prior question was low-PAN, so low-powered wide area networks. So when you look at this environment, and you have to consider what are the devices that are attached to it, how much data is being transmitted, how much and how frequently does that happen. So one thing that we didn't really talk too much about is that the NearSky Edge is an edge processor. It's a computer. And so oftentimes you can gather data, pre-process it on the edge, and only send back the metadata, the data that's quite important. The data transmission could go over the Streetlight controller network, and again, is how much and how often. Those networks that we support have different capacities. And then you might find that for higher data rate networks, you'd have to use the LTE or a fiber connection that's a polar Wi-Fi. So it's really more important to get into specifics. Okay, back to the DSRC question. We're having conversations with a number of people that provide DSRC communications. A couple leaders in that space are Denso. They provide access points for outdoors, and they provide the radios that go in the cars, and there are people that are working with them. What do we have here?
ArcGIS. So ArcGIS, we do interact with ArcGIS. The small city in Florida that I mentioned is using ArcGIS as their geographic information system, and the data that we're gathering from our NearSky 360, that's exactly where it's ending up in ArcGIS. So yes, we do support that.
So that's Esri, right?
That's Esri, yeah.
Yeah. Okay. Yeah, I think this is maybe a good segue into a program that we're announcing today. It's called NearSky Connect. And the idea behind it, if you go back to what I said earlier, that, you know, it takes a village to make a smart city, you know, a lot of different players. We are forming with others a group of like-minded convergent companies to make cities better places to live and work. And we are actively looking to work with other members in the areas of energy and sustainability, mobility, so that'd be traffic and parking, health, environmental air quality, infrastructure, satellite communications is an example, platforms, that could be a smart city platform, it could be Esri, it could be asset management, EV charging is another one. So there's a bunch of possibilities. So if there is interest in exploring this, if they'll go to CIMCOM's website and look under Partners or NearSky Connect, it's just being announced today, we'd love to talk to you, and happy to have that conversation. That's an activity that I lead.
Is this MAPC approved?
Yeah. So if the question is it a Metropolitan Area Planning Council based in the Boston area, this is a membership organization of about 150 plus cities that are inside Interstate 495, mostly eastern Massachusetts. These products are part of that program, their lighting upgrade retrofit program.
Right. I think that's all the questions that we have right now.
I'd just like to add on to that we have a similar relationship in other states, not just in Massachusetts, with regional planning councils.
Okay, great. Thanks, Bill. All right. Well, we'd like to thank you today for taking your time to meet with us and hear our webinar presentation. We will have available in the next few days a recording on our website of this webinar if you'd like to take another listen of it. Otherwise, if you'd like information more quickly, you can contact us either at sales@CIMCONLighting.com, or you can call into our inside sales department at 978-320-4002, and it's option 1. So again, we thank you very much for your time today, and look forward to engaging with you again at our next webinar. Thank you.
Most appreciated and great questions. Thank you for submitting those.
Thanks very much.
Thank you. Goodbye.